Okay, we have section 5.1, and we're going to start with problem 349. So section 5.1 is about adding and subtracting polynomials. So I just chose problems that are going to be very similar to the ones that you're going to have in the exam. So if you are able to solve these problems, then you're gonna do well. So I chose problem as, what is the first one? 57 on page 349. So 57 is just subtraction. So we have x squared minus 5x minus 3 minus 6x squared plus 4x plus 9. So that's my first problem. So the first thing that we do is we need to break this parenthesis. We need to remove the parenthesis. To do that, we need to apply the distributive property. In this case, we're going to apply the distributive property to distribute this negative sign across this polynomial. So I'm going to write the first polynomial in the same way. And then I'm going to switch the sign of every term inside of the second polynomial. So I have a 6 here. It's going to become negative 6x squared. I have positive 4. It's going to become negative 4x. And I have positive 9. It's going to become negative 9. Then you just combine like terms. So I have x squared minus 6x squared. This is going to be just negative 5x squared. Then I have negative 5x, negative 4x. I'm going to combine two negative numbers. I'm going to get a negative number which is going to be greater than the other two. So it's going to be negative 9x. And then I have my constant terms, negative 3 and negative 9. Then if I combine two negative numbers, I'm going to get another negative number. In this case, it's going to be negative 12. So that's the first problem. Now you're going to solve a problem. You're going to solve problem 58. I'm just going to write here the problem 58, and then you're going to send me your answers via chat. So it's going to be 3x squared minus ax minus 2 minus the second polynomial is 11x squared plus 5x plus 4. So solve this problem and send me your answers. So now from section 5.2, which is about multiplying polynomials, I'm going to solve one and you're gonna solve other one. So we're gonna solve problem 77 from page 359. So we have now two trinomials. We're gonna multiply two trinomials. We have x squared plus 2x plus 1 that multiplies x squared minus x plus 2. So as we cover in class, the best way to solve these products is we're going to write the first polynomial vertically. So I'm going to write x squared plus 2x plus 1. And I'm going to multiply every term by the second polynomial. So x squared minus x plus 2, x squared minus x plus 2, and x squared minus x plus 2. So then we're gonna just do these multiplications. So we're gonna apply the distributive property in all these cases. So I'm going to have x squared times x squared is going to be x to the 4. X squared times negative x is going to be negative x cubed. And 2 times x squared is just 2x squared. In the second case, I'm going to apply the distributive property too. So I'm going to multiply this and this and this. So 2x times x squared is going to be 2x cubed. 2x times negative x is going to be negative 2x squared. And finally, 2 times 2x is going to be 4x. And the last product is going to be just 1 that multiplies every term inside of this parenthesis. So this is going to be just x squared minus x plus 2. So now in a single line, we're going to combine all these terms. So the first one is x to the 4. Then I have in a diagonal way, you're going to see the like terms. So here you have 2x cubed minus 1x cubed. You're going to get use 1x cubed. Then the next diagonal corresponds to the powers of x, the second powers of x. So we have 2x squared minus 2x squared is cancelled to each other. So we end up with only plus x squared. Then I have the next diagonal. I have 4x minus x is going to be just 3x. And finally 2. So I have x to the 4 plus x cubed plus x squared plus 3x plus 2. So that's the final answer. So now you're going to solve problem 78 and you're going to send me your solutions via chat. So the problem is another 2 trinomials. So we have x squared plus 3x plus 1 that multiplies x squared minus 2x minus 1. So solve this problem and send me your answers. So now from section 5.3 about special products, I'm going to solve one problem, you're going to solve another one, and in that way we're going to almost finish chapter 5. So the problem that I'm going to solve is just a product of two conjugates. So you have r cubed plus 2 that multiplies r cubed minus 2. So you can see here that these are two conjugates, to conjugate binomials. Why? Because they have the first and the last term are the same, with the difference that the second one just show a different sign in every case. So this is like having a plus b that multiplies a by minus b, and we know that the answer should be a squared minus b squared. So my a in the first case is r cubed. So I'm going to square a minus, and b is 2. I'm going to square 2. So you only need to apply the rule of exponents for this problem, as you know them. So we have, in the first case, you're going to multiply 2 and 3. So you're going to get r to the 6th power minus 2 squared is going to be just 4. So the answer is r to the 6th minus 4. So now you're going to solve a similar problem. You're going to solve problem 40. So problem 40, you have m cubed plus 4 that multiplies m cubed minus 4. So solve this problem and send me your answers via chat. So now from section 5.4 about polynomials in several variables, we're going to solve the following problems. So we're gonna solve problem 65, and you're gonna solve 66. 65 is on page 376. It's just a multiplication of polynomials. So the product is just x plus y that multiplies x squared plus 3xy plus y squared. So there is a binomial multiplying a trinomial. So the way that we're going to solve this is following the general rule for multiplication of polynomial, which is writing one of the polynomials vertically and the other one horizontally, multiplying each term of the first polynomial. So we're going to have x squared plus 3xy plus y squared, x squared plus 3xy plus y squared. So I'm going to apply the distributive property in both cases. So if I do that, I just need to keep in mind that I need to write x first and y after. That's the right order. And also coefficients go first. So x times x squared is going to be just x cubed. Then 3xy times x is going to be 3 coefficient, then x squared and y. Then the last one is just x times y squared. In the second case, I'm going to multiply y and x squared, but I need to write first x and then y. So I have x squared times y, then 3 times xy times y is going to be 3 is the coefficient, then there is only one x, and then there is y times y, which is going to be y squared. And finally, y times y squared is going to be just y to the third power of y cubed. So now I'm going to combine like terms. Again, I'm going to go this in a diagonal way. So the first one is just x cubed. Then I have 3x squared y and x squared y. So it's one more. So that means that we're going to have 4x squared y. So be careful that you are adding the corresponding terms, the like terms. So then we have 3x y squared plus x y squared. So it's 3 plus 1 more is going to be 4x y squared. And finally, I have only y to the third power, which is y cubed. So that's the problem. So now you're going to solve problem 66. Problem 66, you're going to multiply another binomial. In this case, it's the same binomial as before, x plus y, that multiplies a trinomial, which is x squared plus 5xy plus y squared. So solve this one, send me your answers via chat, and then we're going to continue with the next section. So now we're going to work problems from section 5.5 about dividing polynomials. So I'm going to solve problem 77, which is on page 386. And the problem is just 20 x to the 7 y to the 4 minus 15 x cubed y squared minus 10 x squared y. And everything is divided by a monomial. So this trinomial is divided by the monomial minus 5 x squared y. So how do we solve this division? Usually we distribute the denominator across of this polynomial. So I'm going to divide every term by the denominator. So I'm going to get 20x to the 7 y to the 4 over minus 5x squared y. Then I have negative 15x cubed y squared over negative 5x squared y. and finally minus 10 x squared y over negative 5 x squared y. So then you can apply the rules for dividing monomials by binomials, which are just dividing coefficients and then dividing variable by subtracting exponents. So in the first case, I have 20 divided by 5. That is going to be negative 4. Then I have my variable x, and I'm going to subtract exponents. So I have 3 from the numerator minus 2 from the denominator. Then the other variable is y, and it's going to be just 4, the exponent 4 from the numerator, minus 1, the exponent from the denominator. Then negative 15 over negative 5, negative over negative is going to become positive. 15 over 5 is going to be 3. Then I have my variable x with exponents 3 from the numerator and minus 2 from the denominator. Then I have y, the other variable, with exponents 2 from the numerator and minus 1 from the denominator. Finally, negative 10 over negative 5 is going to be positive 2. Then I have x squared y. So you have x squared over x squared is just 2 minus 2, and y is just 1 minus 1. So what is the answer for this? The answer is just negative 4x y cubed plus 3x y, and finally plus 2, because x to the 0 and y to the 0 each are equal to 1. So the answer for this problem is just negative. And I have a problem here because this is 7 or 3.
Yeah.
So this should be 7 minus 2. So it's going to be x to the 5th power. So negative 4x to the 5th y cubed plus 3xy plus 2. So that's the answer. So now you're going to solve another problem like this, and then we're going to move on to the next section. So the problem that you're going to solve is problem 78 from the same page, which is just ax to the 6th power y cubed minus 12x to the 8th y squared minus 4x to the 14th power y to the 6th, and everything is going to be over negative 4x to the 6th y squared. So now solve this problem and send me your answer via chat. Okay, now we're going to continue with problems from section 5.6, which are about dividing polynomials by binomials. So we have problem 29 from page 396. So this is just 27x cubed minus 1 over 3x minus 1. 3x minus 1. So we're going to write this division in the traditional way. So we're going to have 3x minus 1 that divides 27x cubed minus 1. So our numerator becomes the dividend and the denominator becomes the divisor. So you remember how to do this division. So we're going to start with the leading coefficient of every term. So there is something here that I'm just not doing as we did it in class, which is I am not writing the intermediate terms with zero coefficients, because you're going to see now that you can do it in this way, but the only thing is that you need to pay attention when you combine like terms. So let's start. My leading coefficient is 27x cubed over my leading coefficient of the divisor, which is 3x. So the leading coefficient of the dividend over the leading coefficient of the divisor. So from here you get 9x squared. So that goes to the quotient. So I'm going to write that quantity here, 9x squared. So now I'm going to multiply that result and my whole divisor. So, and then I'm going to get 9 times 3 is going to be 27, x squared times x is going to be x to the cube, and finally negative 1 times this quantity is going to be just negative 9x squared. And then you're going to write this here with opposite sign. So you're going to change the sign. So I'm going to write negative 27x cubed and then positive 9x squared. Then you're going to combine like terms. In this case, 27x cubed cancels, vanishes. And then I have just 9x squared minus 1, because these are not like terms. So I'm just going to write them in the proper order, in descending order of powers. So now this is my new dividend. So my new dividend is going to be now with leading coefficient 9x squared, that's the leading coefficient of the new dividend, over the leading coefficient of the divisor. So this is going to be 3x that goes to the quotient. So I'm going to write here positive 3x. And now I'm going to multiply that result and the whole divisor. So I'm going to have 3x that multiplies 3x minus 1. So you're going to get 9x squared and minus 3x, because negative 1 times 3x is just negative 3x. So then I'm going to write this again in the next row, but I'm going to switch the sign. So in this case, I'm going to write negative 9x squared, and instead of negative 3x, I'm going to write positive 3x. Then I'm going to combine like terms, so these two cancel. These are not like terms, so I need to write first 3x and then negative 1. So now my leading coefficient, my leading term of the dividend is 3x over the leading term of the divisor, which is also 3x. So when you divide these quantities with the same numerator and denominator, you get just 1. So that goes again to the quotient. So I'm going to write here plus 1. So then I need to write the product of that number 1 and the whole divisor, which is 3x minus 1. So I'm going to get 3x minus 1, and then I'm going to write it here under with an opposite sign. So we're going to change the sign. So the signs, because there are two terms in every case. So I'm going to get negative 3x, positive 1, and then everything cancels. So we're going to get 0 as my remainder. So the final answer then is this. So the final answer, you can write just 27x to the cube minus 1 over 3x minus 1 is going to be equal to 9x squared plus 3x plus 1, and no remainder. So it's just 0. So that's the final answer. So now you're going to have to work on problem 30. Problem 30 is another binomial. So it's going to be ax cubed plus 27, and you're going to divide by 2x plus 3. So that's the problem. Do it. Send me your answers via chat. So now we have section 5.7 about negative exponents and scientific notation. So I'm going to solve one problem, and then you're going to solve one more. And with that, we're going to finish the review of chapter 5. So problem 119 on page 409 is just a division of two numbers written in scientific notation. So I have 3 times 10 to the 4 over 12 times 10 to the negative 3. So these are two numbers written in scientific notation. Actually, just the first one, the numerator is written in scientific notation. The denominator is not written in scientific notation because for this number to be written in scientific notation, the mantissa, the integer part should be a number between 1 and 9. So this is not in scientific notation. This is not scientific notation, but this is scientific notation. So, but what we want is to have the final answer written in scientific notation. So let's proceed with this division of two numbers. These are 2 powers of 10. That's the only thing that we can say. This is 1 power of 10, and this is another power of 10. So we're going to write the division of the mantissas and times 10 to the, and then we're going to subtract the exponent from the denominator of the denominator from the exponent in the numerator. So we're going to have 4 minus, and then we have negative 3. That's the exponent in the denominator. So be careful when you have negative exponents. So in this case, we're going to get 3 over 12 is just 1 over 4 times 10 to the 7, because 4 plus 3 is going to be 7. So now we need to write this number in scientific notation. To write this number in scientific notation, I'm going to write 1/4 in a decimal by using decimals. So it's going to be 0.25 times 10 to the 7. So I need to move this point, to this decimal point, to this location to get a number written in scientific notation. So if I do that, I'm going to subtract 1 from the exponent in the power of 10. So I'm going to get 2.5 times 10 to the 6. Remember, anytime that you move to the right, you subtract, and anytime that you move the decimal point to the left, you add the number of places that you move to the corresponding exponent of the power of 10. So that's the final answer. So now you're going to work on problem 110 on the same page. So you're going to do another division of two numbers. The first one is written in scientific notation, so I have 5 times 10 to the second power, so that's scientific notation. But the second one, the denominator, is not written in scientific notation because it's 20 times 10 to the negative 3. So this number is written in scientific notation, but this is not. So do this computation, get me the answer in scientific notation via chat, and then we're going to continue with our review session. So the best section to prepare for factoring binomials is just section 6.5. So because in section 6.5 you are applying all the techniques that you learned in the previous 4 sections. So, and the other thing is that the problems that you're going to find in section 6.5 are going to be the problems that you're going to find in your exam in the way that you don't know in advance what kind of technique you need to apply. So section 6.5 combines problems from the 4 previous sections. So it's a good exercise set for you to practice for the exam. So if you have time, try to solve problems, as many as possible, from problem 17 through 112. So there are a lot of problems. If you solve problems within this exercise set, you're going to be well prepared for factoring. I'm going to pick some problems. You're going to solve one similar to the one I'm going to solve, and then we're going to just solve a couple more problems from the final section of chapter 6. So in that way, you're going to be able to work on your exam. So I'm going to start with a problem 24. So I'm going to solve problem 24. So these problems that I'm talking about are on page 462. So problem 24, so they just, the general directions are factor completely. So that's what you're going to do in the exam. You're going to factor completely. If you do a partial factoring, then you're going to have a problem because you can have that answer in your multiple choice exam, but that's not the right answer. You need to do the factoring until anything else is possible. So once you stop and don't find ways to further factor, then maybe you got the final answer. So check many times your work. So we're going to start with problems 24 is just 7 x to the 4 minus 7. So this is the problem. So you need to remember that we start looking for the greatest common factor for all the terms. Then you're gonna check whether you have special products. So remember something like the difference of two perfect squares, that is going to be factor as a plus b times a minus b. So the product of two conjugates. You can check also if you have a perfect square trinomial, so something like a squared plus 2ab plus b squared, that can be factored as play a plus b squared. Or if you have the negative sign here, you're going to get the negative sign here. And also if you have the difference of two perfect cubes, then you have a minus b, and then a squared plus ab plus b squared. Or if you have positive here, you're going to have positive here and negative here. And remember, a squared plus b squared is prime, so you cannot factor this quantity. Remember that. Once you exhausted all these possible choices for you, then you're gonna try factoring trinomials. Factoring trinomials by the AC method or any other method that you know. So we're going to start with these problems. I'm going to look for the greatest common factor first. So I can see here that I can factor 7 out of this expression. So I'm going to write my greatest common factor 7. And then I'm going to divide everything by the greatest common factor. So I'm going to get 7 times x to the 4 minus 1. Then I have this. This is a perfect square. This is another perfect square. So I'm going to write this as x squared minus 1 squared. So that means that I'm going to use the difference of two perfect squares that I have here. So this is going to be 7. Then x squared is, this is a, and this is b. So x squared is a plus b times a minus b. So now, again, the sum of two perfect squares is not cannot be factored, but the difference of two perfect squares can be factored. So if I give this answer to in my exam, and you're gonna find this choice there, it's a multiple choice exam, so you're gonna have this answer as a possible answer. If you click here, you're gonna get wrong. So you need to continue until you cannot further factor. So in this case, this is x squared minus 1 squared. So I have a new a and a new b. So this is, don't forget the previous factors that you just obtained. So, and then now a plus b. So I have x plus b times x minus b. So that should be the final answer. So I cannot do anything else from here. So that's the final answer. But remember, you can get in the exam maybe this as possible answer, which is correct as an intermediate step, but it's not the final answer. You can get also this one as your answer in the exam, but this is also again as an intermediate step. You need to get up to this point. So let's work on a problem. So you're gonna work now problem 23. So 23 on the same page is the following problem. So you're gonna factor completely 2x to the 4 minus 162. So solve this problem, get me all the factors that you can get, and then we're going to continue with the next problem. Now we're going to solve problem 35. So we have 7y to the 4 plus 14y cubed plus 7y squared. So again, the first part is just trying to find the greatest common factor. So the greatest common factor for coefficients, in this case, you can see that 7 works for all these three terms. And for variables, we have y appearing in all variables, and the lowest exponent is 2. So my greatest common factor then is 7y squared. So I'm going to write 7y squared outside of a big parenthesis, and inside of the parenthesis I'm going to write my original polynomial, and I'm going to divide every term of this polynomial by the greatest common factor I just found. So if I do that, I'm going to get my greatest common factor outside, and then 7 over 7 is going to be 1. Y to the 4 over y squared is going to be just y squared. Then 14 divided by 7 is going to be 2. Y cubed over y squared is going to be just y. And finally, 7y squared over 7y squared. This is the same quantity, both in the numerator and denominator. This is just 1. So now I have a trinomial here. You can check that the first term is a perfect square, and this is also a perfect square. So you can write this as y squared, and this is 1 square. So this is my a, this is my b. I can check 2 times ab, so I'm going to get 2 times y1. So this is 2y, and it happens that this is my middle term. So this is a perfect square trinomial, so you can write this just as a plus b squared. So a plus b squared in this case is just, let's write this here. So I'm going to get 7y squared, which is what I have here, multiplying a plus b squared. So 7y squared, a is y, and b is just 1. So y plus 1 squared. So this is going to be the answer for this problem. So remember, the second part of the process is checking special products. So in this case, I check that this is a perfect square trinomial. So now you're gonna work one more problem like this. So you're gonna work problem 36. 36 is just 2y to the 4 plus 28 y cubed plus 98 y squared. So factor completely this trinomial. Send me your answer via chat, and then we're going to continue with more. So now we have problem 55 on the same page, 462. So now we have a trinomial. So again, we're going to start with factoring the greatest common factor if possible. So you can have here the greatest common factor for coefficients. In this case, the leading term is negative, so you're going to use the negative sign. If you don't have an integer that factors everything, you should write 1 here, but in this case 4 is going to work for all these three coefficients. So the greatest common factor for variables, you can see here that y appears in all these terms. So we're going to use just the y with the lowest exponent, which is just y. So my greatest common factor is negative 4y. So now I'm going to write my greatest common factor, a big parenthesis, and inside of the big parenthesis I'm going to write my original trinomial, and then I'm going to divide every term of this trinomial by the greatest common factor, negative 4y in the three cases. Then I'm going to keep my greatest common factor outside, and I'm going to simplify the different fractions. So I have negative 4 over negative 4 is just 1, y cubed over y is just y squared. Then positive 28 over negative 4 is going to be negative 7. And then you have just y, because y squared over y is just y. Finally, negative 40 over negative 4 is going to be positive 10, and y cancels from both the numerator and the denominator. So this is a trinomial. This is not a perfect square, 10, so we cannot use special forms. So the first one, greatest common factor, is here. Special forms not possible. No special forms here. No special forms. So we're gonna proceed with factoring a trinomial by using the AC method. So we have here A, B, and C. I need two numbers that when I multiply them I get AC, in this case positive 10, and when I add up those two numbers I'm going to get B, which is negative 7. So I need two numbers, both are going to be negative because my middle term is negative, so it's going to be negative 5 and negative 2 because the product gives me positive 10 and the sum of these two negative numbers is going to give me negative 7. So I can rewrite this as negative 4y that multiplies. My first term is y squared. Then the middle term is going to be broken in negative 5y, negative 2y, that's the middle term, and then positive 10. Then you just do factoring by grouping. So we're going to have from the first group, this is my first group, this is my second group. The greatest common factor for the first group is just y, that multiplies y minus 5, and the greatest common factor for the second group is just 2, that multiplies y minus 5. So you can see that the common binomial is going to be y minus 5, y minus 5. Then the binomial containing the greatest common factors is y minus 2, and finally I have negative 4y over here. So that is going to be the answer for this problem. Now you're going to solve a similar problem like this one. So you're going to solve a problem 56. Problem 56 on the same page is the following. You're going to factor negative 7y to the cube plus 21y squared minus 14y. So factor completely, and then share with me your answer through chat, and then we're going to continue with one more problem from this section. So now I have problem 97 from page 463. That is going to be the last problem that we're going to solve from section 6.5 about a general factoring strategy. So we have 10x cubed y minus 14x squared y squared plus 4x y cubed. So first, we're going to find the greatest common factor, if there is any. So the greatest common factor for coefficients, you can check that only 2 divides evenly these three coefficients. Then the greatest common factor for variables, we have x and y appearing in all the terms, so we have x and y. Now the exponents, the lowest exponent of x is just 1, is here. The lowest exponent of y is 1, is also here. So the greatest common factor is going to be 2xy. So I'm going to write my greatest common factor, and then I'm going to divide every term of the original trinomial by the greatest common factor, and then I'm going to simplify everything, every fraction that we are getting here inside of the parentheses. So everything is divided by 2xy. So I have 2xy, 10 over 2 is going to be 5, and then x cubed over x is going to be x squared, y over y cancels, then I 14 over 2 is going to be negative 7, and x squared over x is going to be x, y, I have here y squared over y is going to be y. Then finally I have 4 over 2 is going to be 2, x cancels, so I end up with only y squared. So now you can see that there are no perfect squares here, so there are no special forms that we can use. So we're gonna go directly with the AC method, to factor the trinomial. So I need two numbers. When I multiply them, I'm going to get AC, and AC is 10, positive 10. And if I add up those two values, if I add them up, I'm going to get B, which is negative 7. So what are those values? Again, it's going to be negative 5 and negative 2, because the product is 10 and the sum is negative 7. Okay, so I'm going to break the middle term into pieces. So the first term is 5x squared, and I'm going to write negative 5xy, because those are the variables for the middle term, minus 2xy again, plus 2y squared. So I'm gonna do factoring by grouping, and so we're gonna get to xy. So what is the greatest common factor of the first group? Is gonna be 5x. So that multiplies, you're gonna divide 5x squared over 5x. I'm going to negative 5xy over 5x. Then for the second group, the leading term is this one, so we're gonna factor negative 2, and in this case only y appears in both terms, so it's only y, because x only appears in one term. So I'm going to divide negative 2xy over negative 2y plus 2y squared over negative 2y. So that's those are the fractions that I need to simplify now. So I have 2xy that multiplies 5x, so 5 over 5 is 1, x squared over x is just going to be x, and negative 5 over positive 5 is going to be negative 1, and I have used y here, minus 2y that multiplies negative 2 over negative 2 is positive 1, y cancels with y, so I end up with only x. Positive over negative is negative, 2 and 2 cancel, y squared over y is going to be just y. So I can see that I have my common binomial here, So I'm going to write the answer as 2xy, then the common binomial, which is x minus y, then the binomial including the greatest common factors from the previous step, which is 5x minus 2y. So that should be the answer for this problem. So now you're going to work a similar problem to end chapter, section 6.5. So you're going to work problem 98. 98 is 18 x cubed y plus 57 x squared y squared plus 30 x y cubed. So factor this trinomial completely. Send me your answers via chat. And with that, we're going to complete section 6.5. So now from section 6.6, we're going to solve some quadratic equations by factoring. So we're going to solve an application exercise because you're going to have one problem like this in your exam. So we're going to solve problems 67, 68, and 69 from page 474. On page 473, the problems indicate that a ball is thrown straight up from a rooftop 300 feet high. The formula h equals negative 16t squared plus 20t plus 300 describes the ball's height above the ground, h in feet, t seconds after it was thrown. The ball misses the rooftop on its way down and eventually strikes the ground. The graph of the formula is shown. So you can see here the graph of the formula. So it's shown with tick marks omitted along the horizontal axis. So we're going to use the formula that was given, the formula that you can see now, and the graph. So we're going to use this formula, h equals negative 16 t squared plus 20t plus 300, to solve the problem 67 through 69. So I'm going to solve problem 67, then you're going to solve 68 and 69, and you can send me your answers via email later. So the problem 67 is how long will it take for the ball to hit the ground? So we use this information to provide tick marks with appropriate numbers along the horizontal axis in the figure shown. We only answering the question, so we are not going to use, we're going to work the second part. Just how long? We need a time where the ball is going to hit the ground. So the equation is here. So we have the equation. That's the equation that models the trajectory of the ball. So in this problem, in problem 67, they talk about the ball. The ball hits the ground. So h is the height of the ball. Height of the ball. So what is the height when the ball hits the ground? So when the ball hits the ground, h is just 0. So that's the height. So for problem 68, you're going to be given a different height. From problem 69, you're going to have another different height. For this one, when they say the ball hits the ground, the height is just 0. So the problem that we're going to solve is 0 equals negative 16t squared plus 20t plus 300. So that is the problem that we're going to solve now. So we're going to factor the quadratic equation first to be able to find the solution. So first you look for a greatest common factor. So what is the greatest common factor for this equation, for this algebraic expression on the right hand side? So the greatest common factor for coefficients, you can see here that the greatest common factor is going to be negative 4 for coefficients. So what is the greatest common factor for variables? Just 1. There is t doesn't appear in the third term, so your greatest common factor is just negative 4. So I'm going to write negative 4 that multiplies negative 16t squared over negative 4 plus 20t over negative 4 plus 300 over negative 4. And everything is going to be equal to 0. So now I need to divide to complete the fraction, to simplify the fractions that are inside of this parenthesis. So negative 16 over negative 4 is going to be positive 4t squared. Positive over negative is negative, 20 over 4 is 5t, and finally positive over negative is going to be negative, and 300 over 4 is going to be 75 equal to 0. So now I need to factor this. I don't need to write this anymore, because if you divide everything by negative 4, both sides, you just get rid of that coefficient. So you end up with only this simple equation. So 4t squared minus 5t minus 75. So we're going to use the AC method. So I need two numbers that when I multiply them, I get AC. So I'm going to get 4 times negative 75. And also those two numbers, when I add them up, I'm going to get B, which is negative 5. So what are those two numbers? So I need two numbers to get negative 4 times 75 is just 3 times 25, which is 5 times 5. So I have many possible combinations to play with. So let's see. I have maybe negative 20. So I'm going to use these two. That gives me 20, and 3 times 5 is going to be 15. So if I multiply this, I'm going to get negative 300, which is the product of 300. Sorry, the product of 4 and 75 is 300. So, and the addition of negative 20 and 15 is going to be negative 5. So these are my two numbers. So I'm going to break the middle term in negative 20 and positive 15. So I have my first term is 4t squared. Then I'm going to break the middle term into pieces. One piece is going to be negative 20t, positive 15t, negative 75, and this is equal to 0. So now I'm going to do factoring by grouping. So what is the greatest common factor of the first group? It's going to be 4t, and then I'm going to divide 4t squared over 4t and negative 20t over 4t. For the second one, the greatest common factor is going to be 15. 15 that is going to divide 15t, and it's going to divide negative 25. So, and this is equal to 0. So I have 40 that multiplies 40 over t squared over 40 is just going to be t. Negative 20 over 4 is going to be negative 5. T cancels here, plus 15. Then again, 15 cancels, I get only t. And negative 75 over 15 is going to be just negative 5. So, and this is equal to 0. So my common binomial is t minus 5, and the other binomial is going to be just 4t plus 15, and this is going to be equal to 0. So now I have two possibilities, either t minus 5 equal to 0 or 4t plus 15 equals to 0. So from the first case, I'm going to add 5. So I end up with t equals 5. From the second case, I'm going to subtract 15 from both sides. So I get 4t equals negative 15. Then I divide by 4. So I'm going to get t equals negative 15 over 4. So these are seconds. These are seconds. So we don't have negative time. No negative time. They were asking how long will the ball take to to get the ground, so no negative times. So this is not usable, so we only have t equals 5 seconds. So the answer for this problem is 5 seconds. So now you're going to work on problem 68 and 69. And with that, we're going to finish our review session. So let's write here other problems. So it's just 68 and 69. I'm going to show you again if you don't have your book, so for you to get the information to solve problem 68. So you're going to use the same equation. The only difference is that you're going to set a different value for h in each of those cases. So work those two problems and send me your answers because we are running out of time now. So send me your answers by email. So you have here problem 68 and 69. So in one case the height is 304 feet. In the other case the height is 276 feet. Okay, so and that's all for today.